Finally got my ducks in a row. Now that my chickens have all hatched, or it's however the saying goes. Going to sell in a hand basket with hatched chickens in a row, something like that. So we're talking about, let's see, 219, 10, 14 on Monday. Let me copy that here. So we started looking at shifting gears, and I talked a bit about the approach to problem solving and how I really wanted to integrate that as part of what we talked about this semester, and specifically shifting from, we didn't do a lot of real hardcore problem solving the first half of the semester because we're just trying to figure out how to create an integer. But if I had to label what we'd been doing, I referred to it last time as functional decomposition, simply looking at a problem and breaking it up into functionality. And that would generally map to one or more functions. And then the shift I was making was taking an object-oriented perspective, or an object-oriented approach to problem solving, and began kicking that off with a look at this kind of fake email thing, and talked about this idea of a web counter and how really you don't see it much anymore, but certainly did back in the day. And then I gave a definition of abstraction, and I was just honing in on this silly quote here: abstraction and encapsulation, cornerstones of good code. I would probably rephrase that and say that abstraction and encapsulation are the cornerstone of an object-oriented approach to problem solving, but that doesn't sound nearly as cool. So, and I provided a definition of abstraction here, defining something in terms of how it's used. Let me go ahead and add a definition for encapsulation, and I'd really say that there are probably two parts to that. It'd be the bundling together in the same capsule, therefore that's where the term's being derived from. Data with the behaviors that operate on that data. That's the first part. The second part of encapsulation would be that data is only accessible to the behaviors. Those, and I'll just say outside of the capsule, may only access the object through the behaviors. So in terms of we walk in as web developers and we get this email as a problem that we need to solve, the first step would be identifying those abstractions that are in this application, and I think it screams out to us the big thing that this thing is going to have is this idea of a web counter. Okay? So we want to describe it in terms of how we'll use it. What are the things that we can do with the web counter then, based on your reading of this email? Describe it to me in terms of how we use it. How do we use a web counter? What can we do with it? What are the things we do to it or with it? I heard a mumble. Increment it. Okay. Increment in. What term did they use in the email? It to this idea of the counter. What else? You're not going to be able to divine it. It's all in the email, right? Reset, good. What else? We'll use consistent language here. And then there's one more. Set. All right, so not too difficult, right? You can read the email and pretty quickly figure out, yeah, those are the kinds of things you do with the web counter. So that's the abstraction part. Let's look at the encapsulation part. So bundling together in the same capsule data with the behaviors that operate on that data. So these are the behaviors that operate on the data. Anyone want to hazard a guess what the big complex set of data is for this particular thingy, this abstraction? Yeah, just shout it out. You don't have to raise your hand. Yeah, an integer. So there's probably some sort of an integer representing the number of hits, right? The number of absolutely. So what I want to do is this is simple. I think we have an idea of it, but I really want to drive it home. I want to do a little bit of a role play. And just to give you a sneak preview, Project 4 is going to be us taking an object-oriented approach to solving that problem. And it is, relative to this, it's a much more complex problem. Okay, the behaviors are more complex. There are multiple abstractions that we're identifying. They're interacting with each other. And we'll do role playing. It'll be a lot more meaningful for Project 4. But anyway, I want to go through the motions at least and do kind of a role play here, which means by role play, I mean actually getting a couple volunteers to play the role of my 1990s era web page. I got a pair of web pages. You're going to be the counters on them. Yeah, just walk on up. You don't. I usually have a problem getting anyone to come up here, so just come on up and we'll. All right, 2 right off the bat. I have to say this is probably the first semester where I got 2 people at the same time. Usually I get no one, and then I badger, and then someone kind of comes up, moping, looking at their shoes while they walk up. And then I can't get a second person. So, hats off to 2 volunteers right off the bat, all right? Okay, excellent. I like 111 to be considered your trash can. So, try right outside the door. I think there's usually one. All right. Somehow, the banana peel is obviously the other piece of data. So let me see here. I'm going to try and get some cool 21st technology going here. It's going to get better. wonder if I did that for like 2 lectures straight right at the beginning of the semester, and people are going, what the hell? Oh, there it is. I suppose, let me see, what if I do video? Does that change anything? All right, so what I'm going to do, if you all could, let me do this. So we want this to be visible. Let's see, I think that'll work. Just like, let me move this over a little bit. All right. I'll go ahead and get rid of the banana. Okay, so, and I'm sorry, could you remind me of your names?
I'm Bryce.
Bryce?
Yeah.
Bryce and Dominic. Okay, so Bryce and Dominic are my web counters, and this is going to represent your data, right? So I have encapsulated here behaviors and the data that those behaviors operate on. And those are, I have 4 behaviors, and I, as an outsider, am interacting with this abstraction, if you will. I brought 2 of them into existence. We'll actually look at this at a coding level before the period's out. So what I want to say is Bryce reset. So when I ask Bryce to reset, what does Bryce need to do? Put a 0, right? So that file folder there just simply represents the number of hits, the number of visitors to the page. So go ahead and hold that up so everyone can see it. And now, thank you. Well, I'll edit in some dramatic music. Dominic, set 32. So what happens when I say to Dominic, set 32? Hey, this isn't rocket science, right? I'm not trying to stump you. Yeah, so go ahead and write 32 there, and then just hold it there. Okay, Dominic hit. So what would Dominic do? Right, change it to 33. And then scratch that out and change it to 34 because I had said hit twice, and that is actually increasing the web counter there. And then here's an interesting one. What if I say Bryce set -5? What do you think? Say that again. I heard someone say 0. Who said that? Oh, come on. I'm not calling you out. I heard it over here, I thought. Well, what do you think? What is that? Let's think of this in terms of the abstraction. These are web counters that are counting the number of visitors. All right. So there's a bit of an issue in that we can't have a negative number of visitors. So if I do provide a -5, what do you think the behavior would be? Yeah, just to set it to 0, right? So if the number provided is less than 0, we'll set it to 0. So I say, who did I say that to, Bryce? So I said Bryce set -5, so you go ahead and set it to 0. You're already at 0, you just reset it. And then I can say Bryce hit. Let's give you something more than one. And then I could say Dominic get. So what does that mean? So look at line, the way I describe the behavior, it is to retrieve the current number of hits. Okay, so there's a little bit of, what does that look like in code exactly? So Dominic wouldn't print it out because the behavior isn't to display the current number of hits. It's to give it to the requester. So when I say get, you say, what was the number? I get the 2. Now it's up to me to do with what I want with the 2. I could use cout and print it to the screen, or I could assign it to a variable, or I could add to it, or do arithmetic with it, or whatever. But that's up to me. My interaction with Dominic is simply to say get. I get the number, then it's up to me to do with it what I want. Got it? All right. So here's another question for you then. Go ahead, hold your numbers up there. What did I just do?
You manually change the number without using one of the properties?
I manually changed the number. So look at number 2 on data encapsulation. Did I access the object through the behaviors? No. I made an attempt to change the data directly, to interact with the data directly. It doesn't matter whether I just want to look at it or change it. That is illegal. So that what really would have happened when I reached in here to write 42, I get my hand slapped away. Right? I'm not allowed to do that because it'd be violating encapsulation to do that. Okay? Also, let me make a comment about the set. So I think we can all agree this is a really simple problem and easy to get our heads wrapped around. And yet, for all of its simplicity, we came up with a scenario that we hadn't considered before, and we had to reason out what the issue was. When you're actually taking an object-oriented approach to problem solving, and this actually is true of any approach, not just an object-oriented, no matter how well you think you understand the problem, once you sit down and try to describe it and document it, design a solution for it, you are going to hit endless times. You're going to hit these scenarios where it's ambiguous or you don't have an answer for it. Some of them are small and you can kind of decide within the developer group what the solution is. Others, you'd go to the client. So you go to them and say, hey, you want this web counter thing, but what if you all try to set it to a negative number? What should we do? And you have a little discussion with the client and you come up with the decision and then you move on. Okay? So I just want to say that that's a key aspect for the rationale for why you sit down and you do a design, and why I characterize software engineering as a very human endeavor, because the actual coding is the last thing that occurs, and what you mostly end up doing is interacting with people to solve these ambiguities and these problems and so forth. Okay? All right, so I think that's all I need for this role play. I appreciate you all coming up. Okay, the applause was a little more tepid that time, so you're going to really have to up your game next time. Oh, I meant to get a laugh for that. Now I feel bad, like I hurt someone's feelings. Okay. All right. All right. Let's try writing some code then. So let me start with something that we've looked a little bit at, which are structures. And we had like a struct person, and we said that that person has an age, that person has a GPA, and what else do they have? A name. So this comes from the C language, and it's not archaic. It's alive and well. It's used quite frequently in C and C++ in actual applications programming. There's nothing wrong with it. But this idea of describing these abstractions and having this encapsulation, let me see, I wonder if I can, let's try this. Yeah, that's horrible. That's a little better. All right, so we want to describe this web counter in terms of code. And the reason I threw up the structure is because kind of the syntax for doing it is quite similar. So there's a keyword class, and you can see that the editor is giving it a special highlighting to show that it is a reserved word in the language there. I'm going to call it web counter. And then I'm going to have my open curly brace. I'll eventually have my closed curly brace capped with a semicolon. And now I need to describe my behaviors. So I have hit, reset, get, and set. And now I think I'll zoom in at this point. These end up being implemented as functions. So recall that this is the return type are the x's, and then this is the name of function here. And then these would be input parameters. So we have these all comprise the names of the functions. We have to know what kinds of things they return. Let's start with hit. When I said Dominic hit, what was given back to me each time? That was the counter +1 was the behavior, what was actually done. But as far as my interaction with Dominic, I said Dominic hit. Did Dominic give anything back to me? No. So I would go ahead and say void. How about input parameters? Did I say Dominic hit and, oh, by the way, here's a picture of my mother? Did I provide any information when I said hit? The answer is no. So we can leave that empty. Or, if you recall, what is equivalent is to actually put the word void there. I won't put the word void there. More frequently, you just see empty parentheses, but either would be legal. Reset. When I said reset, no information was given to me, and I didn't provide any information. What about get? What was given back to me? An integer. And then what information did I provide? Nothing. How about set? What information did I provide? An integer. And nothing was given back to me. So that would be our functions. And then we said that we had an integer representing the number of hits as the data. So let's go ahead and actually create that integer. And we have to give it a name. We can call it, how about number of visitors? Visitors. All right. So now we've got these things in the same capsule. However, we have to explicitly tell C++, let me bring this up. We have to tell C++ what outsiders or users of this web counter are able to access and what they aren't able to access. And what we have as a general proposition for encapsulation is that the data is inaccessible and the behaviors are accessible. So let me come here. And there are a couple keywords to help us do that. They are public and private. And normally what you do is you do a little indenting there to make it more readable. Okay. Just to say, those words, public and private, that's up to us where we put them. If we wanted to, I could make the data public, and I can make these functions private. And in fact, just to be complete, I can use these words multiple times over. So in this wacky case, the hit function would be private, reset, get, or public. The set is private, and then my data is public. Let's go. You don't see that very frequently at all, so let me go ahead and go to what we would typically see, which is this. So, again, what these keywords are specifying is that those who endeavor to use a web counter, anything that's public, they can touch directly. In my example, I can interact directly with Dominic and Bryce and say hit, reset, get, and set. However, I am unable to reach in and do any specific interaction with number of visitors because that's designated as private. Okay. This ends up being information for the compiler in the same sense that a function declaration or a function prototype is information for the compiler. It is merely telling the compiler, hey, should I decide to create a web counter, this is what it should look like. So therefore, it typically ends up being, I would call this the class declaration, and it would be typically in a header file. And I'd probably call it, I'd give it the same name as a class. And then there are other things you'd have in there like the header guards, the pound if end def stuff, and the end if wrapped around it. Now, what we're missing is we have to describe the actual behaviors. So let me pause for about 60 seconds and just introduce something that I want you to hang on to. I'm going to create a function called, I don't know, Atom. And what it's going to do is it's going to return FL and it's going to add if I was to throw lines 11 through 14 into an otherwise working program, it likely wouldn't compile. And why would it likely not compile? The compiler doesn't have the slightest idea what mystery value is, right? That's why it wouldn't compile. All right, hold on to that thought. I'm going to come back to it in just a moment. So you're going to have an assignment which has you write these functions, so I'm not going to bust them all out for you, but I am going to go ahead and give you one. I would call this the definitions. So I'd create a web counter.cpp is where I would define these functions. Okay. So let's look at the hit function. The function hit on line 21 doesn't return anything. It's called hit. Does not take any input parameters. Give me one line of code that does this function. What happens when I said, say that again? Is that not what Dominic and Bryce did when I told them to hit? They scratched out whatever they had there and added 1 to it? Yes? 26. No, all right, I'm getting there. I'm getting there. Give me 20 seconds. So note, there's no return statement here. Now, I could have a return statement. Let me put a return statement and rephrase it. I'm not returning anything, right? I just said Dominic hit, Dominic increased the number of visitors, and then didn't give me anything back. So there is either there's no return statement, or if there is, there's nothing, no value being returned. And that's, of course, shown here with void. Now let me get back to the thought that I asked you to keep, which was, well, if this function wouldn't compile because the compiler doesn't know what mystery value is, isn't that true of this function, that it doesn't know what number of visitors is and it won't compile? That's absolutely correct, Todd. It won't compile, as I have in this conversation with myself. So what you have to do is you have to tell the compiler that, hey, this isn't any ordinary function. This is actually one of the behaviors of our web counter class. And the way you do that is before the name of the function, you say web counter : : Now it'll compile because every web counter has a variable called number of visitors. And just to say it, note that web count, the class that this function belongs to, is butted up against the name of the function. I'm making that explicit because a lot of times I'll see, oh darn it. Here, the name of the class has been butted up against the return type, and that's incorrect. It's up against the name of the function. Okay? So let me do that again. All right. Now, let's go ahead and look at what I don't know, call it whatever. I'm going to create a main function. I have to bring a web counter into existence. I asked for 2 volunteers. Web counter. Did I spell that correctly, Bryce? Yeah. Did I spell that correctly, Dominic? Yeah. So when I asked for 2 volunteers, that's what I did. Just like creating an integer, right? I could have said, I want to do a role play for an integer. And I have 2 volunteers, and then I say int x, int y, or whatever. All right. So now, then I said Dominic reset. And I said Dominic hit. Dominic hit. And then I turned to Bryce and I said Bryce set 32. At some point I said Dominic, I'll use Bryce. Bryce get. Okay, and then what do we decide happens with get? Let me come up here. On line 23, get actually gives us a number back. It returns the number of visitors. Yeah? So this is legal. That'll compile, but it's not useful. An example of something else that's legal but is not useful is this. That'll compile just fine in the language, but I'm not doing anything with the 9. And so it's not very useful. Same thing here. The number is being given back to me, but I'm not doing anything with it. What I need is I need to like create an integer called val, and then I say val equals whatever Bryce gives me when I say get. Or I could do something like cout, and I could actually put it right inside a cout statement if I wanted. Right. So I talked a bit about expressions last time, and let me just say that this is an expression. What is the result of that expression? The result of that expression is an integer. So what can I do with Bryce.get? You can do anything with Bryce.get that you can do with an integer. So for instance, with an integer, I can say val equals 5 plus 4. I could also say that val equals Bryce.get plus 4. You see what I mean by anything that I can do with an integer, I can do with Bryce.get. Because the result of that expression is an integer. Can you print out an integer? Of course you can print out an integer. That's why I did that. Can you assign an integer to an integer variable? Yeah, that's why I did that. Yes? So all this code should actually compile. Now it won't create an actual, I cannot create a working application because I'm missing 3 function definitions. I haven't written the reset, get, or set functions, right? But unless I have any bugs in here, we'll try it in just a moment. This should compile down to machine-readable code. There'll just be missing pieces, so I can't create a running application. So let me try that. If I say G++, let me go to something more interesting here. It's G++. If you recall the lecture on the 4 steps of the, not the lecture, the video bits on the 4 steps of the compiling process. Oh, let's see. Oh, I've got some pros in there that I need to comment out. And then I don't have stuff like can include IOStream using namespace standard. Try third time. Strings. Oh yeah, there it is. There's the error for mystery value. Very good. All right, so I will comment out that function. And then the last thing is, let me actually just pull these up higher and that'll make the last problem go away. All right. There we go. So it actually did create webcounter.o. That is machine readable code. Again, it's not a working application because I then need to compile into machine readable code the definition for those 3 other functions, and then I could link them together into a working application. So, when will I talk about Lab 14? I'll talk about it in lab. There aren't very many people coming to lab, so I'll at least get 1 visitor today. All right. Any other questions? So yeah, just hit me up in lab, and I'll be happy to talk about it. Oh, let me very quickly. Let me see. What do I have? I have 2 minutes. All right. I'm going to use those 2 minutes. So hang in there. So this assignment is due Saturday night. There is an in-class assignment on Friday. That's due Saturday night. There is this week's lab that's due Friday night. So you really ought to be coming to lab and working on the thing that I'm showing you now if you finish the lab. So let me click on that. a13.tar.gz. a13.tar.gz. I'm going to move it here. I'm just going to copy and paste this to extract the archive. There it is. It creates an A13 directory. It has a make file. Let's take a look at what you need to do. You have to write these 4 functions. I've obviously written the 1 function for you. You need to write the other 3. You get your program entirely working. So let's look at webcounter.h. You have to put the class declaration in there. We've written that in class, so that's a copy and paste job right there. Webcounter.cpp, I've written the 1 function. You need to add the other 3 to here. And then this stuff right here, for the moment, comment this out. So just take this entire thing, comment this out, put the function I wrote in here, write your other 3 functions in here. Now you should be able to get this thing running. Let's look at the test counter program. There we create a web counter, we do reset, we do a cout. It says it should be 0. You can see here that wc.get, so these are put right in cout statements. It does hits. It basically tests out your functions to make sure they're working. Get this thing entirely working. Then the last step is you need to add 2 things we haven't talked about, which is the web counter class has to have 2 more functions called load and save. In both cases, they take as an input parameter a string, and load would open up a file and read in an integer and set the number of visitors variable. And likewise, save would open up this file, would write out the number of visitors variable. Right? Just 1 simple number to either write or read. All right, so that's what you need to do. We will see you in lab.